So welcome everybody to this GLASSNET use case on assessing the interaction between global economy and biodiversity and ecosystem services. So I am Aline Mosnier. I work at SDSN for the FABLE consortium. FABLE is also part of GLASSNET, so this network of networks. And I'm really thrilled to hear Justin and Erwin today to showcase a great example on how two networks and also tools from these different networks can work together and be coupled to have a more comprehensive understanding of the key challenges that we have on the food and land systems for the future.
Discussion for question and answer. And so with it.
Okay, thank you. So how it will work. First, we will have the presentation from Justin Johnson from the University of Minnesota and Erwin Corong from the Purdue University and the GTAP team. So they will show the recent work on how to further improve this representation of these interactions between the global economy and the biodiversity and ecosystem services through the linkage of INVEST with a recursive dynamic version of GTAP AZ. They will have about 45 minutes, I think. Then we will hear the remarks and questions from the three discussants. So today we have Stefanie Onder and Nfamara Dampha from the World Bank, and Iman Haqiqi from Purdue University and the GTAP team. And finally, we will open the questions to all. So please note down your questions and keep them for a lively discussion at the end. So maybe now I give the floor to Tom.
Hey, thanks, Aline. Thanks for that great introduction. And I'll just underscore the fact that this is one of the really initial and important collaborations under GLASSNET, where you have two networks coming together, the natural capital network that has developed the INVEST model suite of models, and the GTAP network that has developed this global economic modeling framework, bringing those together to show, I think in this case, that the combination is much greater and very, very revealing. So the, oops, I'll just mute that person too. So yeah, please be sure you're muted. So very exciting work just came out in the Proceedings of National Academy of Sciences, and we'll get to hear from Justin and Erwin about this work and where it's going in the future. So thanks, Aline, for sharing.
Okay, thank you very much, Tom. And so now, without further ado, Justin and Erwin, the floor is yours.
Great. Thank you, Aline and Tom. We are really excited to talk about this. I think this is a great example of GLASSNET, network of network success, networks coming together to do something that is greater than the sum of the parts. And so, again, just to reiterate very quickly, I want to talk very briefly here about the state of play and some recent publications that we've had. And then this will set up for Erwin to talk about one of the key things that we've been working on lately, which is making GTAP INVEST a recursive dynamic model instead of a comparative static model. I also want to have a behind the scenes, just very brief 5-minute demo of a new Python library that we have created. This is sort of towards the eye of what did it really take to link these models, and this is the actual code. And so we're hoping to make this available to all very soon. We'll end our comments then with next steps and policy relevance comments from Erwin and from me, and then we'll go on to the discussants and questions. So that's what the agenda is for here. So the state of play, though all of us might agree on a lot of these premises, I still think it's very important to keep ourselves reminded, why do we need to link economic and environmental models at the global scale? And I think it's motivated by many reasons, but one of which is that planetary boundaries exist, and we should not surpass the ecological ceilings that have been identified for us as posing a great risk for us. This is the outer circle in this figure here, the ecological ceiling on these different metrics of planetary boundaries. But we also simultaneously need to stay above a social foundation, providing sufficient access to foundational goods and other things that make for a good life, such as food, water, education, etc. And recently, actually just a couple months ago, a great new paper came out formalizing this framework, talking about how we need to stay within the safe and just corridor in between that ecological ceiling and the social foundation. And this is from Rockstrom et al. In Nature. So that's the objective. But what's the challenge? I think I love this framework, but sometimes it gets me all worked up because I want it to be more specific. And so I would argue, and what we'll talk about here, is that staying within that safe and just corridor requires detailed models of how the Earth and the economy are linked. So not just indicators, not just summarizations, but really fleshing out the details for applied policy analysis. And the framework we'll talk about today will include this full linkage, both top half and the bottom half, that links the economy and Earth systems. This will include looking at impacts such as deforestation. This is where a lot of the prior work has focused, but also dependencies such as how the economy depends on functioning of the Earth systems, such as through ecosystem services or other valuable aspects that we get from natural capital. And so the model that we'll talk about aims to add quantitative detail to this. And essentially, the key element is what you'd expect, is it adds these two models from our two networks, the GTAP model and the INVEST model, which is the integrated valuation of ecosystem services and trade-offs. And so this is more or less also the overview of our model, but to add a little bit more detail, I want to just highlight 4 key parts. And so filling this circle out, I'll talk briefly about part 1, which is downscaling land use change. This has become one of the critical enabling factors, being able to move between the different modeling levels. And I'll talk about the model we use there. The second part, I'll talk briefly about the current state of which ecosystem services we run. We're going to be running 6, and we have some advances queued up for more, as well as within those 6. So that's the top half. Then going from INVEST back to GTAP, we have this important step of upscaling ecosystem service changes as economic shocks. Say more about that. And Erwin will also provide then comments on this 4th part, the calculating of endogenous impacts and endogenous land use change with a updated GTAP AEZ recursive dynamic model. So jumping right into those, the first of those 3 things that I'll be talking about is the downscaling of land use change. And I really want to emphasize this because the ability to go from coarse resolution depictions of land use change, such as these coarse pixels here, or even coarser things such as countries or agroecological zones, getting this right has really been an enabling feature. And we just came out with a new publication, Patrick von Gietz et al. 2023 here, that documents this in more details, and more will be coming soon. But getting this right was a critical element that enabled the ability to go from the calculation of endogenous land use change from GTAP AEZ to the scale that is necessary for ecosystem services. And some of the key advances that we had to work on is getting a empirically calibrated model. I'll say more about that in a second, but one that can still incorporate the type of conservation actions that we might want to do. Some of those actions happen at the national scale, such as subsidies or taxes to encourage different behavior, but others of those might be very highly spatially resolved, such as payments for ecosystem services or putting riparian vegetation alongside streams to filter nutrients. The basic idea that the land use change modeling we have here is one based on a machine learning approach that follows the idea that we can look at some sort of baseline map, say the year 2000, and based on a flexible functional form, we can compare a projected land use change in the observed time period, so estimating how the year 2000 transitions to an observed land use map, say 2010, and then compare the projection that we came up with to what actually ended up happening, and then iteratively search for the best parameterization that minimizes some sort of similarity metric between the observed future and the projected future. What had to be done in this work is thinking about how to make this work in a recursive dynamic framework. And so that's the first big work project in the RD component, is essentially making the SEALS model recursive dynamic so that outputs from time period T are inputs to time period T+1. That's kind of the key element, but also to be able to take the endogenously determined land use change at each step from the GTAP AEZ RD model that Erwin will talk about. But just to give I just want to showcase this because we've got it now. I'll give a quick illustration of what this looks like, this dynamic computation of land use change. But just note also that there are all sorts of additional dynamics that we need to consider here, such as transition regimes from one land use type to another, timing of these changes, or even reconversion, as land use changes might convert once from forest into pasture, and then again later on from pasture into. What this looks like, though, when the tires hit the road, is being able to create maps like this one, where we have a present day. And I'll try to do an animation. Let's see if the screen on Zoom keeps up with me. But this is just a very early prototype of the slow transition process by which the land use changes. I'll go backwards so we can kind of enjoy the fading in and fading out of this. So in other words, that's one of the key elements we had to do, is figure out these dynamics of the land use change model. And this is just a very simplified example, but this is now working. And this is able to run at the global scale and still is able to think about, how would specific conservation interventions like that riparian vegetation play out in this now dynamic framework. The second advance is adding 2 new global ecosystem services. So number one, sediment retention. And this means that we can calculate it globally. That's the first hard part. But the second hard part is being able to parameterize what is the relationship between the change in the ecosystem service biophysical estimate and the effect on the economy, or in other words, how do we summarize it as a shock to the economic model? And so this is what I referred to previously as the upscaling of the ecosystem service results to the economic region. The other new one is coastal protection, with coastal vegetation such as mangroves. When that's lost, that can increase damages to onshore capital. And then finally, I also want to note, it's not a new service, but we have very, I think, significant improvements planned working with the University of British Columbia to model the interactions between fishing economy as it comes from the economic model, climate change, and the resultant total catch of fish that we get for those countries that are producing in global fisheries. And the third part, just to emphasize, is we're constantly working to improve that ecosystem service economy upscaling component. And so I've always used this example before. This is the one from our PNAS article of how we go from pollination calculated from the land use change map through to the biophysical provision of service, but then also how can we scale that up to an aggregate level of productivity, in this case, impact on specific pollinator sectors specific to those different agroecological zones. And I want to highlight this because this is, in my opinion, one of the most important research frontiers, is figuring out for the different services, what is that different pathway, or possibly multiple path impact pathways to link that change in biophysical provision of service all the way up to an impact on the economy. And so much of the work here at the University of Minnesota is focusing on strengthening those linkages. So just to close out this sort of brief summary of my part of the work, I just want to reference some of the publications that have come out on this if you're interested in more. This will be recorded, so you can refer to the recording to these links if they go too fast. But up until just recently, much of our work has been in the nonprofit and international space, working with the World Wildlife Fund and the World Bank or the Dasgupta Review. But this most recent one is a PNAS article showing that investing in nature can improve equity and economic returns. To highlight just some of the most recent results that come from this work, I want to highlight the results from that PNAS paper. And our key finding, and this echoes what we've been finding in previous papers, is that nature matters, but especially for low-income countries. And so here's just a real simple plot showing that declining ecosystem services leads to reduced GDP and regional welfare measured as equivalent variation. and that the impacts are greatest among low-income countries. And so what's nice about this comes from a quantitatively rigorous representation of the economy, the GTAP model. And this is really speaking the language that we hope, different central banks or multilateral development institutions are speaking, so that it is useful in their dialogues. And we can produce metrics that are very typically reported, such as, GDP, that goes down by 75 billion when we consider the otherwise ignored impacts of ecosystem services. And just to note, these are not meant to be like total values of the environment. These are extremely conservative measures, as they only capture a small subset of the linkages. And so most notably, it's only capturing the ecosystem services that we can compute globally, and those ones that we can justifiably link back into the economy and link to that endogenized activity in the computable general equilibrium model. The other key finding we had is that not only do low-income countries depend most on nature, the policies that we identify to protect nature, they're good, but especially for low-income countries. And so we analyzed 4 specific policies, researching repurposing agricultural subsidies as revenue-neutral transfers, investing in ag research and development, and then global and local forest carbon payments for ecosystem services, as well as the combination of those. Not surprisingly, it was the combination of policies that was most effective. And as far as individual policies go, it was the global payments for ecosystem services and ag research and development that were the best. But again, we see this really critical finding that the policies had the greatest improvement, so this percentage change in regional welfare compared to the business as usual without the policies, in those low-income countries. And this is a welcome finding, because in the history of environmental protection, many proposed policies have had relatively negative effects on low-income countries. So this is an important thing that considers both the ecological ceiling and the social foundation that we rely on. Let's go to the next one real quick. I just want to end my brief comments here with some of the immediate next steps. Where we have already launched deep into the project on working with World Bank's Changing Wealth of Nations team. And this is really, I want to credit this as the key factor that has instigated and funded the work on switching from our comparative static GTAP invest model to the recursive dynamic model. And they engaged with us basically to see if we could use our GTAP invest model to make projections relevant to what they do, which is the measurement of inclusive wealth. One of our key findings that this requires having a recursive dynamic framework. And I just want to reference Stefanie Onder is one of the discussants on this call. She might have more to say on this. She's leading that project. But just to reiterate, the main challenge we identified was that we need to calculate the full time path of these impacts and not just comparing the initial equilibrium to the ending equilibrium. And so really, and moreover, that we need to do that for both the environment at each time step and the economy at each time. So with that, this will transition, I think, very nicely into Erwin's part, where he will talk about the specific changes necessary in the recursive dynamic formulation of the GTAP AEZ model. So Erwin, the floor is yours.
Okay, thanks, Justin. Welcome, everyone. So I will now give you a brief overview of the GTAP AEZ investor recursive dynamic model that we have been working on. So previously, what we do is we soft couple all these models, for example, GTAP, SEALS Invest, and then back to GTAP in a static framework. It is fairly manageable, although you would imagine the amount of files that are being passed on from one person to another. Now, with a recursive dynamic model, then that number of files will multiply by the number of years that we're running. So there are 2 things that we have been working on the last few months or so. The first one is to extend the static GTAP AEZ model to make it dynamic. And then the second one is to make lives easier, initially for us, and then eventually for the GLASSNET community when we open this up for everyone to try out on. Okay, so what is the GTAP AEZ model. So the GTAP AEZ model, compared to the standard GTAP model, incorporates various land types classified by agroecological zones. So in the standard GTAP model we own for a database, we only have one homogeneous land that can be used across all land using sectors. Whereas in the GTAP AEZ model, we break out that single land input into 18 agroecological zones, which means that land is not directly transformable across uses. And the suitability of each AEZ needs to be highlighted here, because not all AEZs can be used for producing a certain commodity, for example. So the good thing about AEZ is that it facilitates a much better land use modeling compared to the standard model. And as you've noticed earlier, the main link between the economic model, the GTAP model, and this and SEALS and INVEST basically hinges on the land use, right? So that's where we basically communicate with the Earth models, so to speak. Okay, so in the next slide, we thought it might be good to mention some of the history that we had with GTAP AEZ, because we are not reinventing the wheel, so to speak. It started out with a farm model with Darwin et al. When they started out with disaggregating land into different physical characteristics. And then basically in GTAP, it started out in version 6 of the GTAP database. So there's this book co-edited by Tom, and Waylene is here, fortunately, who basically started out working on the GTAP AEZ database and the model. The latest version of the GTAP AEZ, which is forthcoming, consistent with version 11 of the GTAP database, has 5 reference years. So we are now into 2017, excuse me, and we are testing this out, and eventually this will become public as all satellite databases are. So in terms of the GTAP AEZ model, there are various improvements that have been done across the years. So starting with the initial model by Waylene, and then Tom worked on this in the economic analysis of land use book. And then Juris Baldos added a few more features, particularly the upward sloping land use supply curve that Justin showed earlier, and that I will quickly allude to later on. So basically, there were more extensions that were added along the way. For this current work, what we did is we synced the standard AEZ model into the new version 7 model infrastructure, and then added all the dynamics that we need from the recursive dynamic version of the GTAP model. So in the next slide, here, just reiterating that GTAP AEZ has been used in many studies. It underlies a lot of studies that have focused on biofuel debate, productivity growth, land use, and GHG mitigation. And more recently, we've been using it a lot on biodiversity and sustainable development issue analysis. Other models are also using the GTAP AEZ database. So for example, a number of global models, global IAM models have been using the database. So in a way, this is a good contribution because the database is public, and then eventually the work that we are doing here will become publicly available as well through GLASSNET. Okay, so in the next slide, basically, this just talks about how we create the GTAP AEZ database. We update the initial land use data using FAO stat, the most recent available, and we link it to the GTAP database. So in the end, we have harvested area by crop, AEZ, and GTAP regions for the physical units, and we also calculate the land rents for each AEZ in each region. Okay, and in the next slide, basically, the bottom part is where what distinguishes GTAP AEZ from the standard model. So this production structure just shows the input cost decisions of each firm in each economy in the GTAP model. So here, firms are minimizing their cost, the cost of all their inputs to maximize their output. And at the bottom, you see here that land can be substituted across AEZs that are suitable for use in that particular sector. More importantly, in the GTAP AEZ, we do not allow land to be perfectly transformable. So here in the next slide, you will see that we have a land use supply specification here, wherein crops and livestock are combined within agriculture before it can move on into forestry, for example. So we allow for a more realistic modeling of land use in the GTAP AEZ compared to the standard CGE models. But despite all that, we stick with the core of the GTAP model. And here in the next slide, you will see the GTAP circular flow representation. The good thing about what we're doing is, even though we add or extend a number of things in the model, we stick with the main structure of the GTAP model, wherein all agents are interrelated. And you see this regional household at the top, which allows us to analyze welfare implications of policy shocks or any changes to the economy. Again, we stay within the GTAP framework in terms of the value, quantity, and price linkages. So this just shows the interrelationship across all agents in the model from one economy to the next. And basically, we are able to trace the feedback loops within each country and then how it passes or progresses on to other countries in the world. So what is the motivation behind GTAP Invest RD model? So the first thing is that even when we were doing the economic case for nature and the PNAS paper, we were always asking ourselves, would we be able to analyze adjustment paths associated with changes in each economy in the world and biodiversity and ecosystem services? Unfortunately, if you're using a comparative static model, you can only analyze changes from one equilibrium point to another. But it is difficult to understand how the global economy, for example, moves from the in-between equilibrium steps. And admittedly, economy and environment interactions have a distinct time component, right? It's not just one shot as we might thought, but there is impacts or there are impacts from 1 year to the next. So, for example, there are changes in macroeconomic conditions, government policies, and demographic changes that we typically do not pay much attention to in static framework. And all of those changes, year-on-year changes, will affect the provision of biodiversity and ecosystem services, right? And then any changes associated with that will also affect GDP, employment, trade, and other economic linkages. So there is always this distinct time component that we have to consider. The other part is that we thought it's a good opportunity to do further dialogue with other researchers and policymakers. So for example, with the dynamic model, we can use the shared socioeconomic pathways and analyze how, let's say, a particular SSP and an RCP combination will affect biodiversity and ecosystem. So I think this is one of the main advantages of using a recursive dynamic model, and the contribution that we think is something that is important. And finally, just bringing it back to GLASSNET, if we are able to do this on a year-on-year basis, for example, within our simulations, we are able to identify the global to local to global impacts, right? Because we can focus on a particular country, for example, and see within a certain time period how changes are transpiring from the global to the local and back to the global. And also, this would probably help us identify the missing meso scale effect that Justin raised during the last GLASSNET meeting. So it's a good motivation for us to continue extending this model and going through each and every detail in order for us to better understand how economy and ecosystem services are interacting. Okay, so just in terms of finer details on how we make the models recursive dynamic. So we start off with a fairly simple and standard recursive dynamic model. So it's still a sequence of static models linked together with it between years. But between years, what we do is we update certain things to make it dynamic. So for example, we update endowments, population and labor force from projections. And we are also changing some technology and preferences based on observed data. And then in the baseline and both in the policy simulation, for example, we also implement some policies. So for example, in the baseline, we can implement policies that have been announced before. And then in the policy simulations, we can also implement further policies that may happen in the near future. So basically what we're doing here is, although the model becomes a bit more complicated, we are introducing a bit more details into it based on observed data. And more importantly, at the bottom, you see here, we add an endogenous capital accumulation mechanism, which basically allows us to accumulate capital that is produced and that is usable in the next periods. And then there are other features of GTAP Invest RD that deserves attention at this point, particularly the land use supply curve with asymptote. This was inspired by the magnet model. And here, basically, what we added on is that the maximum land that we calculated is the maximum land that we have is specific to each AEZ region, right? So we, in contrast to other implementations wherein the maximum land is just for the entire global economy, here we have maximum land for each region that we are modeling. There are also other features that we've added from the recursive dynamic GTAP model. So for example, we are using ideal Fisher quantity and price indices to make it easier to communicate with policymakers or central bankers, as Justin will mention later on. We also have a lot of levers that we can use in running the model based that we impose based on observed historical tendencies. So for example, we can have cost-neutral preference shifters in both value-added and consumption. So for example, in value-added, if there is a shift in preferences towards more use of capital relative to labor, then we can do that within the baseline. And we can also implement taste changes for consumption. Let's say consumers would prefer more vegetables or less meat as they go from one period to the next. There are also other levers that we have now. For example, labor bias technical change, wherein, for example, manufacturing sectors, the degree of growth or technical change in manufacturing sectors is much higher than agriculture or vice versa. And we also have the upward sloping supply curves for natural resources, which helps a lot in global modeling. The more recent additions that we have is the segmented labor mechanism, wherein labor can move only within sectors or across certain sectors. And the sticky wage mechanism, which allows us to track changes in employment within the short term, but still maintain full employment over the long term. Okay, so those are just some of the details of the GTAP Invest RD model. Justin will now give you a hands-on demo of, I think this is more interesting for even for me. And he will show you the GTAP Pi or GTAP P. We haven't settled on whether we call it GTAP Pi or GTAP P, but he will give you a demo on how this one works and how it can be used by the entire GLASSNET community. Justin.
Great, Erwin, thank you. So yeah, I want to give a quick behind the scenes demo with this very much work in progress Python library. It's so much work in progress that we haven't even settled on the name. I've been calling it GTAP just because I know that sounds funny and makes me happy. But we'll come up and probably think about branding and stuff like that, but that's all forthcoming. But for the time being, I want to talk about it because this is more or less the glue, the very specific glue that allows this hard linkage to take place. And so Erwin already talked about this, but when we have soft link models, that was okay when we had our comparative static model, where essentially it was us emailing results from one model expert, like me for the biophysical stuff, to another model expert like Erwin for the economic model. And that was, even with just the comparative static approach, very slow, but probably more importantly, error prone. But it was still possible because there were only these two data exchanges. A dynamic model, as Erwin mentioned, would require at minimum 2 data exchanges per time period. And that's maybe possible, but I would say very inadvisable. I think almost certainly you would start to run into errors that would be hard to trace and more importantly, hard to do it in a replicable way. So the question is, how can we hard link these models? And here I want to talk very briefly about leveraging advances in the open science software stack. And I guess it's story time for me. I'm talking a little bit about my history with the Natural Capital Project. And so, we've talked about Invest, but originally that was a toolbox within Esri's ArcGIS program. And that worked okay. But the problem was, it was a proprietary approach that wouldn't work for anybody who could not afford the very expensive license to ArcGIS. And so essentially, we spent many years breaking it out of this proprietary environment. And now it is much faster. That was a kind of surprise. We didn't just replicate it. We actually ended up making some of the key algorithms 10 to 100 times faster. And so that enabled all sorts of work, like, for instance, computing ecosystem services globally. But also it's more replicable because people can just download our code and run it themselves. And relevant to us here today is it's extensible because we can take the code and do something else with it. And so how this actually plays out in practice can be seen in thinking about how we actually run Invest. And so the way that most people run it is with the graphical user interface. And here's the latest version of that. And so we have, I don't know what the current numbers are, but 10,000 users who have downloaded and run our graphical user interface program. But in reality, when you start to get to a more advanced level, users tend to switch over to direct usage of the Python library. And I want to give a shout out to the GeoHub. This will be talked about more in forthcoming meetings, but we actually have Invest up and running on the GeoHub. And so that was basically taking this code, so here I just have a very brief snippet of code of what it actually looks like to run it in Python. This code is running on the GeoHub, and so this is an online platform, so you don't even have to have it running on your computer. So that's kind of a more detailed layer, but the most detailed layer yet is essentially just forking the Invest code, making like a fork in the road, creating a new version that is now yours, and modifying it. And this is what we actually do most of the time. And so this is quite possible in the way this whole software stack is structured. This is just the GitHub repository. And a few highlights, you can see there's the website, the source code, but also things like the issue tracker. So if you have a bug, you can report it and this goes straight to the developers, as well as the documentation, which is not written by anybody on a daily basis, but actually is dynamically updated by the code. And so this is what I would call a best practice approach within the software community. Okay, so with that story out of the way, what we're actually doing here today is taking this model linkage that we've been talking about, and we're going to add this part to the left. But previously, we had everything in Python, except for the things that would be subject to the 2 email exchanges. So I would email a CSV of ecosystem service impact shocks to Erwin or to Eurus. This would a whole lot of work then happens that I'm summarizing as Genpack here. But then essentially when that finished, that would be an email of a CSV of land use change per AEZ that would go into this cycle. And what we want to do, what we've decided is sort of the sweet spot, is to update this stack of computations so that everything except for the model solution itself is brought into Python. And so basically, there's a hugely valuable community of tools within Genpack, and we want to continue to leverage those. And in particular, the solution methods, the different modules that you can use, systematic sensitivity analyses. In the framework that I'm going to talk about, those still will be used and are very complementary to this. But anything that deals with essentially input or output between the models is now in Python. And so before I dive into the software demo, what GTAP is just putting PY for Python, I guess, at the end, but we'll work together to come to better names probably, although it does make me happy how it sounds. Either way, is that some of the key features of that is it works with Genpack or GAMS, so it's a way of iteratively running the solvers provided by other more formal or formalized and established solution methods. We currently have it so that it implements the GTAP v7 AEZ RD code that Erwin mentions. One feature that I have found useful is it does not require the user to ever understand or write HAR, header array files, which is the basic file type of GTAP, and instead switches to a flexible format that can use whatever, including Excel or CSV files. And on a practical level, that has made it very much easier for me personally. But what it also does is that it iteratively runs that solver many, many times, or as many times as you want, so that you can compare many different runs, many different aggregations, whatever you have. And this is the sort of the key thing that was necessary for the recursive dynamic many runs thing to happen. A few other quick features is it runs in parallel. And so 16 times faster on this laptop that I'm presenting on, or 128 times faster on the workstation I'm resting my feet on. But other features is it automatically will output cross-region or cross-shock or other types of plots. And so this is a fun feature, is instead of just having an output of the state of the economy and then expecting the user to be able to generate useful information, it can actually go ahead and I'll demo this, automatically plot the things that get pasted into the paper. So those are the features. And now what I want to do, which is something that is uniformly the most terrifying thing for live presentations, is to give a live demo of the software. I'm going to minimize my comfortable screen here and bring up the code itself. The screens, there we go. Okay, so this is Visual Studio Code. This is what people use to program a lot of different programming languages. And what I'm showing here is an implementation of the GTAP library. And so the file we're looking at is what we would call a run file. And this is, run. We're going to do a run of test GTAP for the basic functionality. And what this is going to do is do everything that typically happens in one of these runs of a linked model. And we're going to save it to a new location. I'm just going to create a new location where we're going to save this project. This is obviously way more information than one can digest in a quick demo here, but it is recorded. But the idea is we're going to do all of this in this new location on our hard drive. Some of the key features of GTAP, I'll just highlight, is it can be run with whichever aggregation or multiple aggregations you want. And so here we just have it pre-configured to have two ready. There's the fully disaggregated version, so 65 sectors and 141 regions, or a shareable and fast one that is just the 10 by 10, and that's what I'll show today. The next things to highlight is that it can iteratively run many different shocks. And so we have here the different experiments, and we're going to just use a really simple shock. This is just for test purposes. We didn't even look at the numbers too closely for what those outputted. But the idea is we're going to have a shock that says ag productivity will increase by 1%, 2%, and 3%. And we're going to run those in parallel. Almost said in sequence, but in parallel. Last two features before I click go is if for somebody who is comfortable writing Tableau files, this is what I have done is written basically a superset of the Tableau language in Python, embedding it in associative arrays or dictionaries, as Python calls them. And so some of these names might sound familiar, like what are the X sets or the X subsets? This is all the stuff that you write in Tableau code to come up with useful aggregations or different experiments. And you'll see below where I use them in specifically defining the shocks, which is right here. You can see I have three different shocks to find. We're going to do it for the 10 by 10 aggregation, and we have our 1%, 2%, and 3% increase in agricultural productivity. And we're just using this new way of using the Tableau language, and you actually see raw Tableau code here for defining the shock files. And so this should be very familiar to anybody within the GTAP community. We're going to do a shock to the AO all variable for this subset of commodities. These are a small subset of agricultural commodities, so paddy, rice, wheat, and coarse grains. And we're going to do it just uniformly by 1% across all the regions. Could somebody go ahead and do, thank you. And then we just define the different shocks. Maybe the last thing to run is to mention is, if you're a key observer, you'll note here we are just going to link to an actual pre-compiled executable. And so that's the magic under the hood is very basic. We just have a pre-compiled GTAP executable that we iteratively run with all these different files, essentially by writing different CMF files. And so that's what many GTAP users use to run multiple files in other instances, is we essentially use Python to write different CMF files and then iteratively run those CMF files. And the very final thing I'll point to is, as I mentioned, it will also output in the visualizations of the results. And so this is a very tiny example, but all we're going to say is we want to look at some regional plots that are going to be comparing the different shocks. And just for illustration, we're going to compare it for the variables QGDP and P factor. And so, yeah, that's this. I'm going to now run it in front of everybody and cross my fingers. So clicking run. So probably the most boring thing, but we're looking at the code. So far it's just writing a bunch of files, and this is the whole process of making it work with CSVs instead. But now we start to see some code that might be familiar to Genpack users. Oops, and I just scroll to the bottom. So now all the GTAP code is running. This is all the solution steps that are happening in Genpack. And okay, so it is run successfully, and now we are just writing all the files out into CSVs. And this is using the Harpy or Harpy model produced by our colleagues in Australia, and it has finished. So that was 10 by 10. It was actually, the model itself runs in a matter of seconds. Most of the time it's just writing all the files. But just to show you what we've done here, you'll notice this is the name that I created for this new run. And we have some things that'll look very familiar. As I said, here are the CMF files. And so if you're familiar and comfortable with the Tableau environment, it's all here. You could at any point revert back to the old way of doing it. And so if you want to just have this be a tool that generates your CMF files for you and then run them the traditional way, that's fine too. And additionally, the outputs themselves for our 3 different shocks are in this folder, in the GTAP runs folder, are the standard SL4s and HAR files that everybody is used to. But where it goes a step farther is it also converts all that into an identical set of CSVs. And so this is what a new file type that we had to come up with, a hierarchical CSV, where we have, this is just for comparison, but here's the HAR file, and then but we have a CSV that describes the data, all the headers on the file, and then in this folder is where the header array data are. And going into there, you can just see some familiar looking variables that previously were in the SL4 file, but now are just as CSVs, which for a programmer are sometimes quite easier to work with because they're just simple text representations of the data. The final thing I'll show about this is the visualization component. As I said, showed in the code, we want to say, let's summarize this information. Let's not just have 3 really big SL4 files. Let's try to compare those SL4 files. And so here, I've just implemented some logic that will merge the appropriate CSVs, essentially. Here's the summary CSV. But we'll just automatically create a visualization. Now, I've spent 0 time on making this look pretty, and we also aren't implementing a particularly interesting shock or anything here. But the point is that it's aggregating information across the 3 different shocks, the 3 different color bars. And here we're just describing it as a percentage change in QGDP for each of the regions of the world. So with that, let me switch back. So this is just my fail-safe in case it failed. What I want to talk about then is, so that's the end of the demo. There'll be a lot more, and it seems to have succeeded, so that's nice. We aim in the next year or so to make this all public, and anybody has any questions about it, feel free to reach out to me. We're still developing it because this is the glue that actually makes the GTAP Invest RD model stick together. We are going to end our presentation section here and then open up to discussants and then to broader questions. But first, we want to talk about some of the policy implications and some of the specific next steps we're planning. Excuse me. And so these are the publications that I mentioned, and I've already talked about the PNAS one, but much of the work that has led to this is very policy relevant because they are these reports that were intended for policy communities, like the WWF report, World Wildlife Fund, and the Economic Case for Nature with the World Bank. But once we put these out, one of the biggest surprises, at least for me, was the degree to which central banks and other multilateral institutions have been interested in this. And so here is nervous little me presenting to 400 some people at the OECD. And this was a bigger venue than I was expecting. I thought it was going to be a working group of about 15 people, and then I logged on to this. Here's another one of me walking into the vault room of the Chilean Central Bank. This was kind of fun. Now it's just a little bit of a show and tell. But they invited us for a 4-day training on how they could connect their main central bank models with our Earth economy models. And I only managed to take pictures of the doors and stuff, so apologies there. But what I want to say is that this illustrates a huge level of interest from these communities, and I think it's incumbent upon us to engage with this community and come up with ideas that are useful to them. So I'll just mention 2 briefly, but this might be part for the discussion. But in particular, on the left here, I think one way we can engage with this community is to identify how specific policies move us towards what we might call an efficiency frontier. So this comes from work from Steve Pulaski and others, looking at how do we look at the Pareto efficiency frontier, describing the trade-offs between economic value on one axis and environmental value on the axis, and how can we look at where is the present landscape, so this point right here, but also where are the possible policies that follow different trajectories, payments for ecosystem services, or different policies that attempt to get us closer to this efficiency frontier. Or we might even think about advancing the frontier itself to higher levels of economic value through, say, increasing prices in the carbon market or overall technological growth. A second one that I would flag that has come up in many of our discussions is the need to identify new metrics of value beyond just, that should have said beyond just economic indicators. And so, bluntly, our main goal in this GTAP Invest work was to be able to report quantitatively rigorous estimates of important economic indicators like GDP, because in a sense, GDP dominates a lot of our policy discussions. And so our goal was to extend to be able to speak that language. But now that we've done that, there's this sort of common pushback from many communities that we need to report more than just GDP. So one I would like to highlight is also from the Natural Capital Project and many other collaborators. Ouyang from the Chinese Academy of Sciences led this project to calculate not GDP, but GEP, gross ecosystem product. And they now report it for all of China. And so I'd reference this article if you want to learn more. But what's kind of fun to see is the uptake has been phenomenal. I don't know the numbers now, but I don't know if it's hundreds or thousands of different specific decision makers, municipalities and such are reporting GEP. And so this is a way of actually specifically reporting things beyond just the economic indicators. And so so that's my thought of last steps. I want to hand it back to Erwin for one last slide. I think this is the order that we had it in, to talk more about connections about moving forward within the potential contribution pathways within the GLASSNET community. So Erwin.
Thanks, Justin. So just to close our presentation, basically what we've realized is that we benefited a lot from our interactions through GLASSNET. And in the end, what we want to do is to bring it back to GLASSNET. And we intend to do that by making GTAP Invest accessible to the entire GLASSNET community, so that it doesn't remain with us. The more open it is, the more advanced it would become. So initially, we thought about this GTAP that Justin just provided a demonstration on, so that it would be easier for researchers to run both GTAP and INVEST models without going through the various details associated with each model. And eventually, when this becomes available, we thought about making a tutorial video on how to use these combinations of models for research purposes. And depending on how much interest there are, we could also in the future provide an online introductory course, may it be a short webinar or a few hours of webinar, or a recorded online introductory course that basically introduces the software or the models that we have. The next point is that fortunately we have a project, an ongoing project that allows us to spend more time on this. It's not infinite, but it allows us to go through all the details and then eventually bring it back to GLASSNET in a simpler way. Everything is complicated, as you know, and then when you're doing a project, there are many things that come up. But eventually, when the project is over and you start cleaning up, then it becomes easier for us to share what we learned from this work that we are currently doing, and eventually share it with everyone. And then finally, our eventual goal is to link this or to have the GTAP IAM, the GTAP Integrated Assessment Model with the climate module in it, and link it with INVEST in the future, so that we can say more about climate policy and sustainable development issues and how these economy Earth models will allow us to understand more on our current research. Yeah, so I think that's about it, and we're happy to hear from discussants and everyone for comments or suggestions that you may have. Thank you.
Thank you very much, Justin and Erwin. I think it was a great presentation. So, and also for showing us a bit the kitchen of all this work. I think it's not that often that we have that in presentations, and of course, very exciting to see that. I think that indeed, like you showed us, the best practices for open science, which I think is great, and how to do it in a pragmatic way on how to make code readable by everybody, even if it's a language, for example, that you don't know. So this is the type of thing that I really appreciated. And also on how to connect two models. And what I see here is that INVEST and GTAP have huge communities of users. So by connecting both and in the way that you showed in a simple way, I'm sure that it will have a great multiplier effect. So to increase the use of both models by this community. So congratulations first, and then I head over to maybe Stefanie. You would like to start? So I will go first to the discussants, if it's okay with you, and then we will open the floor for comments from everybody. So for the discussants, it would be great if you could keep your intervention to 5 minutes. So then it gives enough time for Justin and Erwin to react and then to open the floor to everybody. Thank you. Stefanie, the floor is yours.
Thank you very much, Aline. I really appreciate it. And, you know, I'm talking from the user community point of view. So I'm not the technical expert. That's why I'm working with Justin and Erwin on this. So I work at the World Bank for the environment global practice. And the main motivating question for us to engage on this work and to build on the economic case for nature work that Justin and Erwin have already referred to is that we always get this big motivating question, you know, what if? So what happens if I implement policy X, Y, and Z? And of course, the only way how you can answer these questions ultimately is that you need to draw on models. But especially as an environmental economist, you know, the standard macroeconomic models do not model the interactions between the environment and the economy, which is why the model by Justin and Erwin is so incredibly attractive from the World Bank's point of view, because many of our client countries, especially Most of the low-income countries are heavily dependent on land, on agriculture, on resources provided by the environment, but these sectors are not explicitly modeled. And so if you just use a standard macroeconomic model, you get a very conservative impact of the policies we want to do, and we want to get a comprehensive understanding of the environment and economy interlinkages. And there is an increasing demand for this work, particularly also as we're trying to deal with the challenges of climate change and coming up with the right adaptation and mitigation responses for countries. And so this is really why we feel this work is incredibly important, and why we're engaging on this with them now. For the Changing Wealth of Nations, which is the report I'm currently working on, there was always this question about, so how would wealth change if we proceed, implement one policy or the other? Because as you all know, wealth is one of these complementary metrics we want to do in comparison to GDP. But as we construct it, we generally don't make assumptions about the future. We keep things, constant, and we don't assume just business as usual for producing the baseline estimates. But that is usually not very satisfactory. People know, okay, I know this is now my wealth, but how would that change together with GDP as we implement certain policies? And so this is why I have worked with Justin and Erwin to expand their model to not only provide us GDP impacts, but also ultimately wealth impacts. And then we can explore certain policies to go back to that what if question. And so that is why I find this work is extremely interesting. And as Erwin and Justin can attest, there's incredible demand for this, just like from the World Bank side, but I know from many other users. And I think the big kind of frontier where we're heading to is, of course, making the model dynamic, etc. But of course, this is a global model, and it can tell us something about some geographic regions, but there is sometimes, very specific country level demand. So there will be an increasing demand to make these models more focused on specific countries, on specific questions, and and this can lead to a plethora of projects and tasks, etc. And so what we've been discussing, and which is why I find this conversation today is so interesting, that we need to move to a space where this is more open source, where this is more easily accessible, where it is usable, of course, for technical experts, but potentially also for simple policy simulations by users like me who have a broad understanding, but perhaps not all the technical know-how, but can still run some simulations. So I find this very exciting that we're moving to this space of how we can leverage these models in an effective way and keep building on it. I think that was really all I wanted to say. I hope I stayed in your 5 minutes. But anyway, so from our point of view, this is incredibly important. We will continue to engage and expand. Oh, sorry, one last point. I wanted to mention what I had envisaged initially when I started working on the Changing Wealth of Nations is to have our baseline estimate, and then to have what we produce, policy contingent wealth, where you say, this is the spread of how your wealth can evolve depending on what policy actions we take, what climate scenario we ultimately end up in. And I know that Justin and Erwin's model is going to get me a large step in that direction, in particular with regards to renewable natural capital. But wealth also has produced capital in it. It has human capital in it. It has net foreign assets in it. It has non-renewables in it. And I know it is insane at this point to ask for a model that deals with all of these factors. But I think ultimately that is perhaps the direction we might want to go for I guess a 10-year research agenda. But I think that is something where we ultimately want to move, especially human capital, I think would be very important, since it is such a big share of human capital. And let me stop there. Thank you so much.
Thank you very much, Stefanie. Justin and Erwin, would you like to react now, or you would like to react to Discussants at once at the end?
Maybe at the end. I think there's some wonderful comments there, but I'd like to see the synthesis that arises. Unless, Erwin, you prefer to go now.
I agree.
Okay.
Let's go in the end, yeah.
Good. So maybe we can hear from Nfamara, from the World Bank also. We cannot hear you still.
Can you hear me?
Yes, perfect.
Okay, thank you very much. I first of all would like to congratulate Justin and Erwin and all of the partners that are involved in this work for an incredible body of work that's been done. And I think there are a lot of potentials for looking at a couple of things that still need to be advanced in this work. So first, I would like to say I am, by introduction, I'm a lead scientist at the University of Minnesota with the Natural Capital Project, also leading the project from the University of Minnesota side. And today, I think it's very symbolic that I am joining this call from Africa in Nairobi. just attending the Africa Climate Week, and currently at a site event where the African a consortium people come together to come up with a community of practice called Africa Natural Capital Accounting Community of Practices. And I think a lot of what we're discussing here are the same type of questions and concerns that people have here. So Justin, you mentioned the central banks are interested in this, but here I'm learning how much interest is coming from the national governments. And again, this is work that the World Bank is supporting with the Global Sustainability Program. UNEP is here, UN Statistics Division is here with the team, and these are the right questions that folks are asking. How is nature connected to macroeconomic outcomes, but also how is climate change impacting nature and nature-related assets? So I think for me, from the presentation, there are three things that I would like to highlight. One is that, just like Justin said, nature matters, and especially for developing countries, I think Stefanie also alluded to this. It matters so much for these economies because these economies, their economy is centrally based on land-based sectors. You know, it's agriculture, it's forest resources that they often rely on. I think the second thing that I think really matters related to what you've been talking about in terms of the GTAP EAZ model is the scale. So downscaling this sort of downscaling land use change is so important because when it comes to country level, the more specific, the finer the resolution, the better. And I think that's really important because sometimes when you run the models at a global scale, countries like the Gambia, for instance, when you look at it, it becomes difficult for them to come up with policy-specific or operationally relevant questions to address these issues. So I think the scale really matters, and I think one of the things I've been thinking about while you're presenting is this idea of temporal resolution as it relates to scale, but positionality or seasonality in terms of when the land use cover is considered in the model, because different seasons provide different land use types or land use types, I would say, and that provides different services to different communities. So I think if you can, come and think about how you're thinking of the temporal resolution issue of what that exact point in time is for the land use change, I think will be interesting. The other thing I've been thinking about is further disaggregating the AEZ model from the 18 zones that we have. Is there any capability to advance that to have more zones included in future modeling work? I think that's also something that would be interesting. Other things that you've highlighted, I think there's a potential for collaboration also relevant for the GLASSNET network is the issue of capacity building. I think that as I interact with folks here and explaining what the Natural Capital Project is and what INVEST is, a couple of feedbacks that I've been getting is that it's not as simple as I was explaining. That using INVEST is a little bit complicated. So I think if we can think about bringing INVEST to practitioners who are actually going to be the one to understand what the model does and how it's applicable in their work, I think that would be useful. A lot of usage of INVEST also, as we know, it's been very focused in Latin American countries, and of course in China, we've seen a lot of progress in China. We're now even doing GEP work, which is really interesting. But I think also with my African bias is to think about how can we invest more in capacity enhancement or capacity development and bring in the tool, bring in training. I think, Erwin, you were talking about tutorials and training online courses. I think there's a lot of interest in that area. Actually, in related to the NatCap project, I launched a survey since I came here, and I've received over 30 responses. A lot of things that people are highlighting in this survey is the issue of training and understanding what these models do, and just simplifying the language a little bit, because sometimes when you say modeling, it sounds very scientific for some of the practitioners that we hope that should be the one to use these models. The final thing I would like to highlight is the issue of equity. How do we address equity concerns? In one of your papers, Justin, you've talked about how these nature-based ecosystem service contributions benefit the low-income countries, and I think that's really important. But also within these countries, is there a way we can look at equity dimensions, especially as it may affect people like indigenous landowners, for example. Some of the macro level policies that we do, there are a lot of injustices or distributional impacts that affects the communities that do not often have the voice at the table when making those policies. So I think if we can think about that a little bit. And I think related to GTAP is the SAM account, so the social accounting metrics. And I know there's a lot of effort put in place, but if we can also think about increasing that SAM for a lot of more African countries to have their own social accounting metrics developed, I think that would be very useful and connected to the interest here on the continent about natural capital accounts. So overall, I'll say, I think, again, the social dimensions, you've mentioned the SSPs, linking it to SSPs, but also thinking about climate change linkages, especially as it look into the projections or the recursive dynamic model. I think that will also be useful. But overall, I think this is a great work. Thank you very much.
Thank you very much. So now we'll move to the last speaker, so last discussant, sorry. So Iman.
Hey, I have a couple of slides. May I share my screen? I don't know, Holly. Okay, yeah, perfect, thank you. This is Iman Haqiqi. I work for GTAP and Purdue University. Let's go to the full screen. So I don't have so much comments. It was very impressive work, and I really appreciate all the hard work you're doing, both Justin and Erwin. I believe it is very significant in terms of research, in terms of policy implications and impact. And it is also a good example of how networks can connect systems and models that they are working on. So I have a couple of questions and some comment. So what would we miss without linking these two models? So that would be a good question to answer. And I know this is question specific and it really depends on the topic in hand, but let's talk about that a little bit. And then what will be I noticed that Justin commented on some of these unique future directions and opportunities, but I would like more to know about other opportunities. And when I was looking at this, I realized that there's a potential to consider connection of these two systems, both GTAP and INVEST, to something like Simple G, which is a gridded economic framework. I'd like to know what do you think about this regarding when you have not a uniform policy, when you have a heterogeneous, especially heterogeneous policy, which may affect one location, and then the spillover can be within AEZ, not from AEZ outside. And some of the economic motivations, which are Giritsola specific, they are not uniform or they're not following a normal distribution. So those are the things, the opportunities that can have one of the future directions. But the reason I'm mentioning this here is that Simple G has millions of grid souls. It has land cover, water resources, fertilizer, which is all of them are important for biodiversity. And then it's connected to food system, exports, imports, prices, trade, which is part of GTAP. And I have a couple of other technical comments. I will stop on this and probably follow up with you guys later. Thank you.
Thank you, Iman. So also maybe I will take advantage of my position as chair to just ask one or two questions now also. So indeed, I think this question for me, it has been raised by other discussants on the flexibility of this framework to change the scale. So for example, to especially bring this analysis to the national and subnational level. So having you saw some flexibility to reaggregate the regions of GTAP. So I guess it would mean that one country versus simplified regions, aggregated regions, but also invest how and what would be needed to exactly adapt these tools for national and subnational policy making. And then maybe another question that I have is more on the downscaling part, because this is a big component, and it's great to see all the analysis that you did to make it work at that resolution level. But one question that I have is exactly like when you do the downscaling, so then after this ecosystem services, like the land use change affect the ecosystem services, and the ecosystem services affect your economy, but you don't need over iterations, meaning that like the ecosystem services would not also change the future allocation of land. And so don't you need several iterations to make sure that at some point you reflect really the constraints on both sides? And yeah, that's one question. And then maybe one thing that you didn't mention so much here, but that I liked in your paper in PNAS was about the tipping points and the nonlinearities. So indeed, now that you have this recursive dynamic framework, how do you imagine to tackle these nonlinearities and potential tipping points in the ecosystem services and then link to the global economy? Okay, thank you. I will stop here.
Well, thank you, Aline, and to all our discussants. I jotted down many questions because those are all very good. And Erwin, I guess we can just kind of bounce back and forth. But maybe starting just with some of those most recent comments that Aline raises. To answer the technical one first is you are very perceptive to note that indeed the provision of ecosystem services and how it affects economic activity itself would require another modeling step, because that would determine where other things like the future provision or change of land happens. And you're totally right. And the way we do include that in the model, and the way we do it is we actually, for each time step, we have to run GTAP twice. We run it once for what happens to the economic indicators. That gets us to the next time period, essentially. It also gets us the endogenous land use change that we downscale, that we run our invest models and figure out those shocks. But then we run for the same time period a second run of GTAP, the ecosystem services run, where now the only thing that has changed is the additional effects from degraded ecosystem services. And so, and just like from a sort of interesting technical point, when we report how much does nature matter, that's basically specifically defined as what is the difference in 2030, say, between the first run, which has no ecosystem service damages, and the second run, which has those ecosystem service damages. But you're right to point out, as soon as we get into a dynamic framework, the additional economic changes that happen from degraded ecosystem services will itself feed into the next step and the land use change and all the other components. So, so we have endogenized that. Maybe we could just, Erwin, maybe how we just go back and forth on each of the four specific people's questions. Do you have any responses right away?
Yeah, I'll follow up with your response to Aline. So what we're doing is we're not combining the two models. We're just soft linking them still, because it will be very difficult for us to combine them in one framework and solve them together. So what we're doing is we're soft linking them, but doing 3 steps for each time period, for example, just to make it closer to the solution for each model. And there's always a possibility of us overestimating or underestimating. And it's always a lot of detailed work from one model to another, just for us to understand what's going on. So that's a very good point, though, in terms of the modeling. On the issue on multi-cropping, so what we have in the AEZ database is for a given year, we have data on production, we have data on area and land cover type. So basically, we only observe multi-cropping that happened within the year. We only run the model on a yearly basis and not on a 60-day time period, for example, in terms of the cropping cycle. And the resolution, of course, that's why GLASSNET is so important, because it allows us to go to the GLG, right? The global to local and to the global. Although it's not, still there's a lot more work to be done. At least we're moving towards that one. And then before I turn it back to Justin, it's possible to have more AEZ. So in the AEZ workflow that we have about 108 AEZs. But imagine in a dynamic model, and then we're iterating 3 times every year. The dimensions just become immense, even with powerful computers that we have nowadays. I'll get back to the poverty and inequality and the SAM questions, but I'll turn it over to Justin for now.
Yeah, thanks. I agree with those points. And but coming to some of the issues raised by our discussants, one theme through the 3 that I saw, and this was first raised by Stefanie, is the need for having national specific information embedded within this. And I've mentioned this before, but I think it's really important. We've heard this from central banks, national governments, et cetera, is the need to have, yes, this global consistency, and yes, this linkage between the earth and the economy, but can you do it with our model is the sort of short question we get every single time we engage with anybody. And so because so many different partners have raised this sort of question of, can you embed our nation-specific model into this framework? We've thought a lot about that. And if I were to guess, this is the single most likely immediate next step after the Changing Wealth of Nations project that we're on, or maybe even simultaneous, is to say, let's take a very detailed national model, whatever it is. And so, for instance, when I was working with the Chilean central bank, they have their dynamic general equilibrium models, which are a little bit different in type than CGEs, but they wanted to see, could we essentially take inputs from the global model as the initial parameters of their nation-specific run, then run the national model, and then have those feed back into the global model. I think there's a ton more of potential there, and so absolutely this will be a frontier. To Nfamara's point, well, he and I definitely agree on this point that downscaling is necessary. Or I'd even say just cross-scale analysis itself is really a frontier. I think why it's mostly because disciplinary focus has led us to think about things at certain scales and less about the interconnections. But many of the sustainability challenges we face are fundamentally multi-scale, global, local, global, but yes, also detail at the meso layers in between. I think that's an important point. But maybe the other point that Nfamara raised that really stood out to me was the need for increased emphasis on equity. And so we had a little bit of equity in our paper in PNAS insofar as we looked at low-income countries and their a greater benefit from ecosystem services and their policies. But what we didn't have is anything about equity, say, within the country or within different labor groups or different sectors. And all I can say is this is really important, and we need to go there. One idea that we've had is implementing what's called the GTAP POV model by Tom here on the call. And this adds further information disaggregated exactly to those different labor groups and tracks what happens to specific echelons within society. And so I think you're totally right. We need to do that. And that would allow us to be more than just able to comment on national or international equity, but even within a given country. And then finally, to respond to Iman's points, thank you for sharing those slides. We've talked a little bit about this in the past, so I'm glad you shared those. But the basic idea of linking simple G into this is a wonderful one. And so, but to give more perspective on why I think that is, when you run a model, a lot of times you become very aware of its flaws and where does it have things that don't look quite right or seem like a crass approximation of reality. And for me, one general area where this arises is whenever you cross big differences in spatial scale, you're likely to run into problems that arise, things that don't look quite right. And so if you think about it, in our model, we're going from relatively more spatially refined economic regions insofar as we're using GTAP AEZ. And so in the last iteration, that was 341 unique AEZ region zones. So that gets us a little ways towards higher resolution, but it is a huge jump. There are tens of millions or 100 million grid cells in each agroecological zone. And so that huge amount of spatial scale difference that we have to span is a source of challenge, and also parts of the model that I just don't feel as comfortable about. And so that's why it's always been very appealing to me to think about, well, what if we had an even more finely resolved economic model? And exactly that, of the million or so grid cells of 10 kilometers within simple G, that would be a great additional meso layer to fit in between. There's some details to figure out that that I would love to hash out. And in particular, I think the biggest one is, how can we keep the global general equilibrium aspects that we need for some of our policy analysis, and still connect to the partial equilibrium framework within simple G. And maybe I'm getting this wrong, that there's more nuance here than I'm getting. But perhaps the answer is, just like how I said embedding a national model, maybe it's embedding simple G within the global standard GTAP general equilibrium model. And so that it would go 3 levels, GTAP, maybe even drop AEZ, because now we have all this information with simple G grid cells of GTAP, simple G invest scale and backup. That's just some initial thoughts on that. But there's so much more here, so please follow up, and we'll have to talk about this. But with that, let me hand it back to Erwin for one more response on the discussants' questions and comments.
Yeah, about poverty and inequality. It's a very important topic that we tried to include. So the main idea is for us to have access to household surveys or censuses, for us to be able to say something about poverty and inequality. The easiest way to do that would be to link this set of models to a household survey, or we have a GTAP POV, for example, then we can say something about poverty. But the household survey is necessary for us to say something about inequality, right? And it allows us to go into the details of, let's say, where these particular households are located, what are their characteristics, would they benefit from or lose from all these interactions. So the natural step, as Justin mentioned, would be to have a global model, and then we have this link with Invest, and then we have simple G, and then further on we have household surveys that allows us to do that on a country by country basis. That's a perfect use case example or particular case study, right? Because it allows you to go from the very global to the global landscape all the way to the very detailed landscape with poverty and inequality. Just briefly on SAMS and UNECA, the UNECA has been providing us with input-output tables. They have this ongoing project that has been going on for the last 3 years. So my colleague here, Angel Aguiar, has been working with them on having more input-output tables, African input-output tables being updated and contributed to the GTAP database. So for example, when we moved from version 10 to version 11 of the GTAP database, we added at least 20 African countries into the new version of the database. And it's still ongoing. It's ongoing work. There are a lot of updates going on in the older IO tables. So that's one of the highlights of the new version of the GTAP database that we have. I think those are, yeah. Justin, do you have any more
I do. I think a lot of them will. I'll follow up directly, because I think now would be a good time to hand back to Aline to facilitate the discussion with the full audience.
Yeah, thank you very much. There are two hands waiting since a bit of time. So I think let's go to Ken. Ken?
Thanks so much. This is great work, both of you. Thanks so much for presenting it. Justin, this is more a question for you, and acknowledging that what you've already done is pretty amazing, and that we know well the challenges involved in scaling. We do know that ecosystem services and land use are sensitive to the analysis scale. So do you have thoughts on the 300-meter resolution choice? Do you see any hope for moving beyond it? I know that on its own is a pretty big challenge, but do you see potential solutions like meshes or other approaches that might get us to higher resolution eventually?
Yeah, great question. And yes, 300 meters was what was possible in 2019. We're already investing in higher resolution. And so the next generation will be Copernicus-based 100-meter resolution. And that's, you can do some basic math here, is about 9 times more grid cells. And that step itself will have a significant computational lift that is now heavier, but our computers are advancing, and more importantly, our algorithms are advancing. And so I think that's going to be a very imminent next step. It gets a little harder when you start to think about 30 meters, which is, at least from standard ecosystem service analysis and the communities therein, that's kind of the standard that's used within national level. That aligns well with the digital elevation models that we tend to use for hydrology, for instance. And so there's a lot of focus on that. I think it would require investment in high performance computing to be able to do that. But all of the algorithms, to run global models at 30 meters. But all the algorithms that I've discussed here are already parallelized, meaning they can leverage high performance computing. That has thousands of cores instead of 128 or so. And so that's definitely a next step. That's expensive, but it's absolutely worth considering. Because you're right, the results of ecosystem service models, like anything when we have multi-scale analysis, is sensitive to the scale you use, and 300 meters is a little coarse. Even though it seems really high resolution from an economic perspective, it's a little coarse from a biophysical perspective. I agree.
Thanks so much.
Etienne?
Thank you a lot for this presentation. Sorry, I was mute. I'm Etienne Berthet, a PhD student from Technical University in Denmark, and I'm working at SDSN. I have 2 specific questions, maybe a little bit more for Justin. The first one, it's when you are downscaling the land use change from the SEAL model. I have the impression that you are still at the coarse different categories like cropland or pasture, and I would like to know how you have success to disaggregate to the economic categories. So, for example, cropland, between the difference between soy, rice, because it seems important to make the connection with GTAP after to have this level of detail, and it seems really difficult based on the current data to know the driver, the crop driver of the deforestation. And my second question is more a technical question regarding your amazing work for Python, because we are working with Ilaria Fusakia right now on an iterative model running GTAP with R. And each time we are running, we still use the Genpack executable, but we need, in this little bit the same way than you, we have bypassed the use of the R file by transforming it as a CSV, but we still need the R file to run at each iteration the executable of Genpack. So it seems that you are completely bypassed this, and I would like to know if you have technically done this, or if you are just like working on a CSV file, and then as an output is your R file that you are running in each iteration. I hope my question is clear.
Yes, great questions. And I personally like technical ones the best, so good. To answer in reverse order, the underlying approach that we took with CSVs versus HAR files, the what we did is we said there's going to be 2 steps involved. Take a HAR file and extract it out to some definition of hierarchical CSV. And so that's what I was showing. And that's where all the non-GEMPAC computation takes place. But the second thing that it has to do is to be able to go from the hierarchical CSV back to an identical HAR file. And so we have a test suite in the software to ensure that works. But basically, you could go HAR to CSV and then CSV back to the exact same HAR that you had before, or it could incorporate the changes. And we do this because the solution of the econ model running the executable itself still does require the HAR files, but you never have to write them. And so I guess on the one hand, the answer is no, we still use the HAR files for the computation part of solving the econ model. But in terms of the things that you actually do in the model, like come up with different shocks, you can that it can all be done still in a CSV or an Excel file, and just the last step right before the GEMPAC executable runs is converting it back to HAR file. So it's kind of in between, I would say. The first question you had was about the different crop types, for instance, and that's a great point. And it comes down to a classic question in geography and elsewhere of land use versus land cover. The approach that we've taken right now does not distinguish between different types of crops. And so cropland is just cropland. And we do this more or less because we come from the perspective of remote sensing, where it is much easier to detect from spectral signatures if it's crop or not, but it's pretty hard to detect which type of crop it is, though there is, of course, work that tries to do that. And so that's been the challenge, is without really good land use change time series data that is crop specific at that high resolution, we can't train the algorithm to downscale appropriately with that. That said, there still may be like back of the envelope approaches to be like, okay, let's take a further step of converting the agriculture into what is the most likely land use or crop use. And so I'd point to the US's cropland data layer approach as one example of that. But there's a bunch of work there. And so this is a kind of a new field that has tons of potentially high value research to be done, and that is absolutely one, because we don't do it yet. We're just downscaling agriculture. And the same is true of forest versus managed forest, as well as pasture versus grassland. Those are all things where remote sensing doesn't do a great job of distinguishing the difference, but we know on the ground really matters.
Okay, great. Thank you so much.
I just have a quick comment on Etienne's question. So I would suggest leaving the GEMPAC part untouched. Basically, you have the HAR file, the input files in there, and then you use those files to run your model. What we've realized over the past years is that we get to improve more on our productivity when we start processing the results, right? So that's where the advantage of converting them to CSV files are much better, because in most cases we try to come up with so many results. We spend so much time making diagrams and tables, etc. But imagine if you don't need to do that anymore. You just have one system that basically tidies up all the results that you need, and then you query the results that you want to see, and then you can just paste them in your paper, for example. So the suggestion that I would always say is leverage on what the software is more tailored for. So GEMPAC is more tailored towards solving the model in a much efficient way. And if you have a wrapper like Python or R, for example, then you can call GEMPAC and then create results, post-simulation results, or even come up with data summaries that you can then use in your research.
Yeah, completely. It's really like exactly what we do. We have like our environment, GEMPAC, and then the output. But it's just in R, there is like a package, a write R file, read R file. And I was wondering if you have like the same package in Python and if it was like published at some point on a Git or somewhere. That would be really, really interesting.
Well, and so yes, that is what GTAP is, and so it's not released yet because we've just been using it internally. But that's absolutely one of the features we would like to have in it when it is released.
Okay, I'm looking forward for the Git. Thank you.
So thank you. We still have a bit of time. I don't see hands up. Ah, no, 2 more. Okay, very good. At the same time, so I don't know who was first, but Angelo, maybe? You want to start?
Yeah, sure. Thank you. Thank you, Aline. So first, I would like to congratulate Justin, Erwin, and all the team. I think it's amazing how you guys have improved this interaction between environmental impacts and economics. And I think some of my questions, I saw that Iman already asked. So I have just a remaining very basic question that's about invest, not about all the framework of combining the modules, but just from my perspective, well, I'm quite curious about to know how invest works, and as you have like today 6 kind of ecosystem services, and it includes pollination, climate regulation. I believe they are not independent, right? So one of those ecosystem services have some impact on the others. Does invest take care of that, or does it assume those are independent ecosystem services?
Yeah, great question. It's a little bit of both. So the answer is that, so Invest provides 24 ecosystem service models. The 6 that I mentioned are just the ones that we're able to both run globally and feed back into the econ model. The basic approach, though, within Invest is to run them independently of each other. However, some of them do have linkages. And so, for instance, the water yield model links to the sediment and nutrient retention models because they're both driven by hydrological routing and underlying precipitation effects. Just obvious overall amount of water available will affect all of those things. So there are some of those linkages, but up until now, it still is the case, is that a typical Invest usage, ignoring the rest of this framework, would think about running them iteratively as well, because they are not linked internally. There is a lot of interesting research still to be done on the, ignoring economics for a moment, just within ecology or biology, of thinking about what are the relationships between different ecosystem services. And so one classic one would be the example of biodiversity. Increasing biodiversity probably increases the efficiency of provision of many of the ecosystem services. But this level of cross-service linkage is not directly included in the Invest approach, but there's all sorts of ways to sort of jury-rig the Invest models together to answer that type of question. And, on my slide where I was showing the Invest code, that's one of the basic reasons why you would want to run it not in the user interface, but rather at the code level, because it allows you to make those modifications yourself, but you have to do it that way. I think that was it.
Yep. Thank you, Justin.
Toon?
Yes, hello, I'm Toon van Dijk from the OECD. Thanks a lot for the presentations. It's amazing work. I just have a small question. I think you mentioned that the land use data for GTAP and the GTAP AEZ model update are forthcoming. Is there a timeline for this?
Yes, it will be available soon. We have it internally. I can share it with you in the next few days or so if you want to test it. We're still testing it, but happy to share it with you if you want to test it.
Would any of the discussants would like to react maybe to the answers from Justin and Erwin, or do you have additional questions?
Yes, thank you.
Iman? No, it's okay. Okay.
I'm fine too. I'm looking forward to advancing the work. We're just starting our work, so we're at the beginning. So thank you.
Tom, would you like then to have some concluding remarks before we close?
Sure, Aline, thanks so much. Thanks for chairing this session. Thanks to all the discussants and presenters it was really an excellent session. I think it really epitomizes what we're trying to achieve in this GLASSNet experiment. And so you all were wonderful participants. Thanks to everyone who attended. I do want to draw your attention to another very interesting use case workshop that will take place next week, same time, same place. That will be focused on planetary boundaries and spillovers with a strong emphasis on nitrogen fertilizer use and its impacts. That's, of course, an area where we're blown past planetary boundaries, and they'll be exploring how addressing nitrogen might spill over to other planetary boundaries. So also very exciting. That will be featuring the Simple G model. Iman will be presenting that. So those who are interested in learning more about that as a potential connector here, that'll be a place to learn about it. So thank you. Thanks, Aline, for the opportunity to make those remarks.
Okay, so thank you very much. Thank you very much to all. Indeed, I also enjoyed very much this session. So I learned a lot, and I think that there will be a lot of points to follow up. So thanks a lot. Very good presentation, very good questions, very concise and to the point. So that allowed us to finish even 7 minutes earlier. So thanks a lot. Thanks, Justin and Erwin, for this great work.